All right, the rate of change practice is going to be more word problems, something more contextual, something where it's not necessarily harder, but you do need to think about it just a little bit more. So starting with number 1, we have Jeff Morden drives 140 miles in 4 hours. Part A is what is his rate of change? So his rate of change is essentially his miles per hour, right? The miles he's driving for every 1 hour he goes. So we have the information of 140 miles in 4 hours. So simply put, that is sort of his rate of change. He's going 140 miles per every 4 hours. But we can reduce this, we can simplify this if we divide both of these, the numerator and denominator both by 4, reduce this fraction by 4, we end up with, what is that? What's 140 divided by 4? 33? No, hold on a second. 35. I don't know. All right, anyway, 35. Oh, weird. 35, and of course 4 divided by 4 is 1. So this essentially is just 35 miles per hour. Is his simplified rate of change, his average rate of change. Represent the situation on a graph. Well, that's pretty simple. Let's go, since we got the space here, we'll separate this out. 1, 2, 3, 4. And we'll also put by miles. Let's see, we got to go up to 140. So let's see, 1, 2, 3, 4, 5, 6, 7. So let's do it by 20, 40, 60, 80, 100, 120, 140. Okay, so 1 hour would be 35 miles. So that'd be something like right about there. 2 hours would be another 35 miles, so which would make it 70 overall. So 2 would be right here. 3 would be another 35, so which would be 105, which would be right about there. And at 4 hours, we know it's 140 miles. So 4 hours, 140 miles. There you go. There's our representation. We could draw a line. There's our graph of the situation. So really not that bad, really not that bad. Our rate of change is sort of the miles per hour, of course, in this case. So wasn't too much. So Claire and Rachel play volleyball for different teams. Claire's team practices 7 hours every 2 days, and Rachel's team practices 8 hours every 3 days. Match each player to the graph that represents the average number of hours that they practice each day over a 7-day period. So essentially, which one of these graphs is Claire's? Which one of these graphs is April's? So when we look at this first graph, I'm kind of looking at this line, and I'm sort of looking for any particular point of interest. And I notice one up there, right? That's a solid point that intersects. If I can zoom in, you guys can maybe see it better. Intersects the grid very, very evenly right here at this point. And that's, of course, at 3, 8, right? Essentially, this one matches, let's see, what did they say? Rachel's team practices 8 hours every 3 days. So there you go. That's kind of what we're looking for. 8 hours. This represents hours. This represents days. So 8 hours every 3 days. That's solid. So this one must be Claire's on the this must be Rachel's. Meaning that this one must be Claire's, but we can verify that by looking at its graph too. So Claire's team practices 7 hours every 2 days. So we're going to be looking for 2, 7, which is there. 2, 7 is a solid point of interest on that graph. So 2, 7. That's a match for Claire with an E. There we go. Okay. All right. So that was just essentially a matching one, kind of looking for those points of interest, 3 days, 8 hours, 2 days, 7 hours, and just kind of trying to find out which graph had those points. So I found the graph that had 2.7. That's Claire's. I found the graph that had 3.8. That was Rachel's. And that was it for that problem. Steve is trying to increase his average pace per mile by running hills. The hill on First Avenue rises 3 vertical feet for every horizontal foot. The hill on 16th Avenue rises 1 vertical foot for every 3 horizontal feet. Which hill will be more difficult for Steve to run up? Explain the reasoning. All right, so you have to really understand what vertical and horizontal mean for this. So the first hill, so First Avenue, right? Let's talk about First Avenue. First Avenue. First Avenue is rising 3 vertical feet, so going up 3 vertical feet for each horizontal foot. So for each foot, 1 foot horizontally. So that's 1, that's 3. So essentially going up 3 as you go over 1, right? So its steepness would be something like this line. Whereas 16th Avenue, it goes 1 vertical foot, so 1 foot up for every 3 feet horizontally. So 1, 2, 3 feet horizontally. Right? 3, 1. So it goes 1 foot up for every 3 feet horizontally, making its slope something more like this. So it's longer and less tall, whereas First Avenue is shorter and taller. So drawing this out helps because which one of these hills would be more difficult to run up? Well, First Avenue clearly would be more difficult to run up because essentially it's much, much steeper. So our answer is First Avenue is more difficult because it is much steeper. I don't know how to spell steeper, but it's fine. I mean, you could elaborate more on this. You could say, it's steeper because it goes up 3 feet every time it goes over 1 versus 16th Avenue, which only goes up 1 foot every 3 feet it stretches out. So I think drawing the picture is pretty much the best explanation you can kind of give here. It really illustrates what's happening. Number 4, the following graph represents the amount that Camilla and Lydia charge for their babysitting services. Which of the following statements are true? Select all that apply. So Camilla's the one kind of, let's highlight it here in purple. Right, and Lydia's this red one. Okay. So the rate of change of each line represents the amount each girl charges per hour for her babysitting services. So the rate of change, essentially the slope of the line. Remember, so let's think about that. Rate of change, the slope of our line. So the slope would be, change in y over change in x, as we've talked about this in a previous video, which in this case would mean charge for babysitting. Charge for babysitting over the number of hours. So charge is the y, number of hours is the x. So the change in y would be the charge for babysitting, and the change in x would be hours. So essentially, their slope is charge per hours, which is what this is claiming. Each girl's slope is charge per hour. That's correct. Okay. It'd be incorrect if it said something about kind of the other way around. If it said hours per charge or something, I don't know how that would make any sense, but that is a true statement, what it's saying there. Its slope is its rate of change is its charges per hour. Lydia's rate of change is greater than Camilla's rate of change. So to have a higher rate of change, right, to have a higher slope, essentially, you would have to have more charge over a period of hours. So whoever charges more per hour has the higher rate of change, essentially. So based on our line, who do we think is charging more per hour? The answer should be Camilla. Camilla is charging more per hour because you can see that her line, the purple line, is more vertical. So, and it's above Lydia's line, right? For, let's take, for example, 5 hours of work, Camilla's charging more money than Lydia, meaning if Camilla's charging more money, she's charging more money per hour. So that one, it says Lydia's rate of change is greater than Camilla's rate of change. That is not true. Camilla's rate of change is greater than Lydia's. So second one is false. Lydia's rate of change is $7 per hour. Now, to see if Lydia's rate of change is $7 per hour, we're going to have to look and see, if it was $7 per hour, then we would see 1 hour would be $7, 2 hours would be $14, 3 hours would be 21, 4 would be 28, 5 would be 35, right? If we see these points on Lydia's graph, then we can safely say, yeah, she's charging about $7 per hour. It's kind of tough, though, because, when we look at Lydia's graph, we have to notice, okay, here's 1, right? That's about 7, right? But let's keep going. 2 is right here. It's a little less than 15, so yeah, maybe that's 14. Here's 3 hours. That's a little bit above 20, so yeah, maybe it's 21. Here's 4 hours, which is, somewhere between 25 and 30, so yeah, it's probably 28. And then 5 hours is kind of the giveaway because it's exactly at 35, so 5 hours, 35. So yes, more or less, it looks like these points are on that graph. So it does look like Lydia's rate of change is $7 per hour. Camilla charges $35 for 5 hours of babysitting. Well, Camilla at 5 hours is not charging $35. At 5 hours, Camilla is charging $45. That's false. Lydia charges $35 at 5 hours, but not Camilla. So Camilla does not charge $35 for 5 hours babysitting. She charges $45. So that statement is false. And then the last one, Lydia charges $14 for 2 hours of babysitting. Well, we've already talked about this on Lydia's graph. We can kind of see Lydia 2 hours, $14. That's about right. We've already kind of talked about that with these points. If she charges $7 per hour, which we already know she charges $7 per hour, then for 2 hours she would charge 14. So that is true. We've already kind of confirmed that. All right, so number 5. Keon and Leisha are comparing their daily caloric intake. Each day, Leisha chooses healthy 100-calorie snacks such as apples, carrots, while Keon chooses snacks like chips and candy that have 200 calories each. Draw a graph to represent Keon and Leisha's caloric intake based on the number of snacks they eat, labeling each line and the axis. So it's kind of similar to the last problem where we saw like Lydia and Camilla. So here we're talking about I guess the number of snacks and the calories intaked or taken in or eaten or whatever. So this is going to represent down here number of snacks, and on our y-axis this will represent calories. Because essentially it's just, there you go. That sort of looks like calories. It looks like calories, but it's fine. All right. Because essentially what we're talking about is, 100 calories per snack, 200 calories per snack. It's the calories per snack, essentially being calories being that change in y, and number of snacks being that change in x. So let's label these. Let's label, 1, 2, 3, 4, 5, 6, 7, 8, that many snacks. And then we'll go by calories as well. We'll say 100 calories, 200 calories, 300, 400, 500, 600, and 700. All right. So let's use purple to represent, well, I guess draw a graph. That's part A. So we're still doing part A. Let's use purple to represent Leisha. So Leisha chooses healthy 100-calorie snacks. So for every one snack that Leisha has, she has 100 calories. So one snack is 100 calories. 2 snacks would be 200. 3 would be 300. 4 would be 400. 5 would be 500, right? So on. 6 would be 600. 7 would be 700. So this is Leisha's graph. Now in blue, will represent Keon. Keon chooses snacks that have a little more calories, 200 calories each. So one snack would be 200 calories for Keon. Two snacks would be 400 calories, right? Because 200 per snack. Two snacks eaten would be 400. Three snacks would be 600 calories. Four snacks would be 800. We don't really have that number on a graph, but we're kind of running out of space up there. But yeah, right there is Keon's calorie intake. So what does rate of change for each line represent? Well, we already talked about that when we set up our axis, right? Our axis was a change in y, which is calories, change in y over change in x. Change in y, which is our calories, over our change in x, which is snacks. So essentially, it's calories per snack, which is what's described to us in the problem. 100 calories per snack and 200 calories per snack. Leish's rate of change, as we already know, Leish's rate of change was 100 calories per snack. So 100 calories per snack. How does Leish's rate of change compare to Keon's rate of change? Why are the two rates different from one another? So Leisha is much more healthier, right? Leisha's the purple line, so hers is a lot less steep than Keon's. So you can essentially say that Leisha's rate of change, let's abbreviate ROC, rate of change is half of Keon's, because remember, Keon eats 200 calories per snack, whereas Leisha eats only 100 calories per snack. Is half of Keon's because she eats half as many calories per snack. Okay. Leisha eats 100 per snack. Keon eats 200 per snack. All right. So number 6, Steve repairs elevators. When he is called to a job, he uses the stairwell to go to the floor on which the elevator is located. In the Modis building, he climbs 22 steps for every 15 feet of horizontal travel. In the Sears Tower, he climbs 17 steps for every 7 feet of horizontal travel. What is the rate of change for each stairwell? So, if you remember, let's kind of draw ourselves a little picture here. So, in the Modis building, right, he goes up 22 for every 15 over, right? So think of that as the steepness, right? Up 22 for every 15 over. And in the Sears Tower, he goes up 17 for every 7 feet he goes over. Now, it's kind of tough to tell. These look very similar. They're kind of close in comparison when we just kind of sketch them. But essentially, the Modis Tower, its rate of change is going to be 22 over 15, which I think would be helpful if we're comparing them to convert these into decimals. So we'll do that in a second. The Sears Tower, however, was 17 for every 7, right? So Sears Tower is 17 over 7. Now, if you're wondering which of these is really steeper, some of you might be able to kind of tell. But if you can't tell which one's steeper, just take them and divide them, right? 22 divided by 15 is 1.46 repeating. So 1.46 repeating. And then the Sears Tower, 17 divided by 7 is 2.42. So the Sears Tower is going to be steeper since its rate of change is bigger than the Modis Tower. So which stairwell will be easier to climb? Explain your reasoning. So Modis will be easier to climb because its slope, which is again 22 over 15, is less steep than Sears, which is 17 over 7. And we just proved that by using those decimals. The smaller one is the one that's less steep, so it's going to be easier to climb. The bigger number, which is 2.42, is obviously more steep than 1.46, so the Sears Tower will be much steeper and much more difficult to climb. All right, J.K. Rowling and R.L. Stine are both reading The Hunger Games. J.K. reads 35 pages for every 2 hours, and R.L. reads 45 pages every 3 hours. What is the rate of change for each reader? Okay, so J.K. reads 35 for every 2 hours, and R.L. reads 45 for every 3 hours. Now, if we simplify this, we can say that JK is about 17.5 per hour, because if you just do 35 divided by 2, that is 17.5 per hour. And R.L. Stine ends up being 15 per hour. 45 divided by 3 makes 15. So this tells us who reads faster right now. Now, because we've kind of, put them on the same playing field, the same number of hours, because the first one, JK told us she reads 35 every 2 hours, but RL reads 45 every 3 hours, right? It's different. It's not apples to apples comparison because you're comparing one for over a 2 hour period and you're comparing the other over a 3 hour period. But now we've simplified it down to both of them just being per hour, and we can see that JK reads 17.5 pages per hour and R.L. Stine reads 15 pages per hour. So now we can see, who's actually reading a little bit faster. If The Hunger Games is 355 pages, who will finish the book first? Well, it doesn't matter how many pages it is. We can tell that J.K. Rowling is going to finish it first because J.K. Rowling reads more pages per hour. So, J.K. Rowling will. She reads faster. 17.5 pages per hour. Okay. Jose drives 65 miles per hour when he travels. Sherry drives 450 miles in 9 hours. Which driver has a faster rate of change? So, Jose, we already know is 65 miles for every 1 hour. So essentially his rate of change is obviously 65 miles per hour. Now, Sherry, we know, drives 450 miles every 9 hours. So let's simplify that, right? 450 divided by 9, I think is 50 miles per hour. But let me check. 450 divided by 9 is 50. Yeah. So this simplifies to just 50 over 1 or, 50 miles per hour. So which person's going faster? Jose is going faster. Jose is going faster. All right, one more question. The following graph represents the money Matthew and Mitchell spend each hour when they play video games at the local arcade. Which of the following statements are true? Select all that apply. So we have Mitchell's and we have Matthew. Okay, so Matthew is spending his money at a faster rate than Mitchell. That is not true because you can see that Matthew's line is less steep than Mitchell's line. Mitchell's line is much steeper. If you look at one period of time, look at 5 hours, for example, Mitchell has spent $40 in 5 hours, where Matthew has only spent $25 over that same period of time. So Mitchell's spending more money than Matthew is. So this is incorrect. It should be the other way around. Mitchell spends more than Matthew, not Matthew spends more than Mitchell. The rate of change represents the money the boys spend per hour playing video games. So remember, rate of change is change in y over change in x. And our change in y is the amount of money. And our change in x is hours. So it's money per hour, essentially. And is that what this says? The rate of change represents the money spent per hour. This is correct. That's a true statement. It is the money spent per hour. Mitchell spends $3 every hour he plays video games. So Mitchell spends $3 for every hour he plays video games. Essentially saying, $3 per hour. Meaning that 1 hour would be $3, 2 hours would be 6, 3 would be 9, and we're going to see if these points line up with Mitchell's graph. Well, with Mitchell's graph, 1 hour looks like about $8, in my opinion. 2 hours is about $16 or $17. 3 hours is about 24. 4 hours is about 32 or 33, right? That's clearly much higher than what that's saying. So if it was every 3 hours, his graph would look more like this: 3 in 1 hour, 6 in 2 hours, 9 in 3 hours, 12 in 4 hours. His line would look more like that if it was $3 per hour. He's clearly exceeding that by quite a lot. So that's not a true statement that it's claiming there. Matthew spends $8 every hour he plays. So Matthew, let's look at Matthew. So if he spent $8 per hour, it would be 1 hour 8, 2 16, 3 24, right? So let's see if that's what's on Matthew's graph. That is Mitchell's graph, but not Matthew's. Matthew's looks like 5 in 1 hour, 10 in 2 hours, 15 in 3, 20 in 4. So he looks like he's going at more about $5 per hour. 315, 4 20, 5 25. Matthew looks like he's spending about $5 per hour, not $8 per hour. So that's also incorrect. So the only true statement I see is that second one there. So that's essentially rate of change. That's interpreting rate of change to a certain extent. I hope you find that useful. It's helpful. I don't know. You can tell me how much you're struggling with it. If you do have questions, just let me know. Okay, I'll see you guys in class later.